Hey guys, we have one more video about shapes and their attributes. Today we are going to focus on classifying shapes by their attributes. Let's start with the review of the quadrilaterals we have learned so far. So a parallelogram is a four-sided shape, four vertices. Vertices are those, the points, right? The corners where the sides meet. Two sets of parallel sides, two sets of equal sides. Rectangle, four sides, four vertices, two sets of parallel sides, two sets of equal sides, and four right angles. A rhombus, four sides, four vertices, two sets of parallel sides. All sides in a rhombus are equal. A square, four sides, four vertices, two sets of parallel sides. All sides are equal and four right angles. And the last shape that we talked about was a trapezoid. Four sides, four vertices, one set of parallel sides. And just to remind you, when it says one set of parallel sides or two sets of parallel sides, make sure you're paying attention to the difference between two sets of sides versus two sides, right? So a trapezoid has one set of parallel sides. So this line is parallel to this line. This side and this side are parallel. So it's two lines, but it makes up one set. And in the rectangle, you've got two sets of parallel sides. So that's this side and this side make up one set, and this side make up another set. So even though we're talking about four of the sides, it's two sets of parallel sides, all right? And then we also said right angles are those, just to kind of review that, right angles are those 90-degree angles. If we measured with a protractor, they would measure 90 degrees. And we could also use the corner of an index card or the corner of a Post-it note to line up with the shape, and we would be able to see that those are 90 degrees. Here, these are 90 degrees, as opposed to like, this is not a 90 degree, right? It doesn't make that perfect L. Okay, so we're going to talk about classifying shapes based on their attributes. So just briefly, what does it mean to classify? To classify means to arrange things in groups based on some criteria or property. And you can think of that as sorting things. Some examples in your real life, hopefully if you are organized, your drawers in your bedroom are classified by your clothing type, right? You sort your socks into one drawer and your shirts in another drawer. That is classifying by that clothing type. In the media center, books are classified by the type of writing and information that they contain. So all of our fiction books are in a certain place in the library on certain shelves. All of our nonfiction books are in another place in the library on different shelves. And then even with books, we take it a step further and we further classify them, right, based on other criteria. So with fiction books, we further classify based on the author's last name. So they go in ABC order. With nonfiction, we further classify or further sort the books by the type of information, right? So all the animal books are together, all the history books are together, and so on. So that's classification. When we classify shapes, we're going to think about the attributes that we've learned about with shapes, how many sets of parallel sides they have, how many right angles they have, and so on. And we're going to group them based on those attributes. So if you're going to, you can kind of do this two ways. You can just watch and follow along in your mind with me. I've also sent you some little shapes that if you want, you could already, if you have those cut out, you can use those and manipulate them and follow along and rearrange them and group them as we go. So if you have your shapes, great. If you have shapes, the first thing I want you to do is get a big piece of paper. Well, it doesn't have to be a big piece of paper, but a blank piece of paper, and you want to use the whole thing. Don't draw a tiny oval, but draw an oval. And basically we're going to be, to group or sort, we're going to be making a very interesting Venn diagram. A little bit different type of Venn diagram than you've seen in class, but you know that we've used Venn diagrams a lot to compare things and to contrast things, and we're going to do the same thing with shapes. So if I'm thinking about my shapes and what could be one characteristic or one thing that all of these shapes have in common, hopefully you can see that all of these shapes are all 4 sides and 4 vertices, right? If something is 4 sides, it's going to have 4 vertices because that's just the way it works. So all of these shapes are 4-sided shapes. So the first way that I could classify them or sort them is to say they're all quadrilaterals. All of these shapes are quadrilaterals. So in my big oval to start with, I can put all of the shapes inside and I can label this quadrilaterals because they're all 4-sided shapes. So then I need to think about, well, and just to kind of back up for just one second, with this, all of these being quadrilaterals, there would be other shapes, right, that wouldn't fit into this quadrilateral group, right? I could say a circle is not a quadrilateral. A triangle is not a quadrilateral. A pentagon is not a quadrilateral. So there are other shapes that wouldn't fit in this group. We just happen to be talking about only quadrilaterals right now. So all of these shapes go in this group, but there are plenty of shapes that wouldn't fit in the quadrilateral group. Okay, so now in thinking about all of our quadrilaterals, we need to think about ways we could further group them. So let's look at this parallelogram. The first 2 attributes, the 4 sides and the 4 vertices, all the shapes had that. They're all quadrilaterals. But what else does a parallelogram have? What other attributes does a parallelogram have? It has 2 sets of parallel sides and 2 sets of equal sides. So what I want to do is look at the other shapes, and I want to find any other shapes that meet these same criteria. Any other shapes that have the same characteristics or the same attributes as a parallelogram that I could group with a parallelogram in a parallelogram group. Okay, so let's look for 2 sets of parallel sides and 2 sets of equal sides. So rectangle, it also has 2 sets of parallel sides, 2 sets of equal sides. The rhombus has 2 sets of parallel sides, all sides equal. So does all sides equal, does that mean the same thing as 2 sets of equal sides? Yes, it does, because let's say this rhombus was a 3, a 3, a 3, and a 3. I could say that there's 2 sets of equal sides, right? Because this would be one set, 3 and 3 would be one set, and 3 and 3 would be my second set. So yes, a rhombus has the same attributes as a parallelogram. What about the square? 2 sets of parallel sides, all sides equal. Has the same qualifications as a parallelogram, the same attributes. And then trapezoid. Trapezoid only has 1 set of parallel sides. So trapezoid does not have the same attributes. It doesn't have the same things in common, right? So if I was going to try to group these into another group inside my quadrilateral group, I could group them like this. I could draw another oval inside my quadrilaterals, because they're all quadrilaterals. They all have that 4 sides, 4 vertices. And then I could say, well, all 4 of these shapes are parallelograms because they all meet the requirements of a parallelogram. To be a parallelogram, you have to have these 4 things: 4 sides, 4 vertices, 2 sets of parallel sides, 2 sets of equal sides, and these shapes all have that, right? All right, so how can I go any further? Well, let's look at this rectangle. So the rectangle has 4 right angles. Skip down to that. What other shape has 4 right angles? Well, parallelogram doesn't. That's over here. We're done with that one. A square has 4 right angles. Does a rhombus have 4 right angles? No. So a rectangle and a square can be in a group together. So I'm going to draw another oval, and I'm going to put my square and my rectangle together. But what am I going to label this group? Am I going to call it squares or am I going to call it rectangles? And so this is where you really have to think about, you have to look at all of the attributes and decide which one you're going to call it. So let's look at our rectangle. Let's look at the qualifications of a rectangle and see if a square can be called a rectangle. So in order to be a rectangle, you have to have 4 sides and 4 vertices. A square has that. You have to have 2 sets of parallel sides. A square has that. You have to have 2 sets of equal sides. A square does have that because it has all sides equal. And you have to have 4 right angles. A square has that. So to be a rectangle, you have to have all of these things, and a square does have all of these things. So I could call this group the rectangle group. Can I call it the square group? Could I call it like rectangles and squares? Well, let's see. To be a square, these are the attributes you have to have. Let's see if a rectangle has all of these. You have to have 4 sides and 4 vertices. Rectangle has that. You have to have 2 sets of parallel sides. Rectangle has that. You have to have all sides equal. The rectangle does not have that. So the rectangle does not have the same attributes as the square. The rectangle cannot be called a square. But we did learn just a minute ago that the square can be called a rectangle. So we can call this group the rectangles group, right? Both of these shapes can be called rectangles because they both have the attributes of a rectangle. All right. So now this rhombus is over here by himself. Let's see if he has anything in common with anyone. I should say it. It has anything in common with any of the other shapes. So the rhombus has the 4 sides, 4 vertices, 2 sets of parallel sides, 2 sets of parallel sides, all sides equal. So a rhombus and a square have all sides equal, all sides equal. They have that attribute in common, right? So can I group them together? Yes. But what am I going to call this group? So am I going to call it rhombuses? Am I going to call it squares? Am I going to call it rhombuses and squares? Let's think about it. In order to be a rhombus, you have to have 4 sides and 4 vertices, which a square has. You have to have 2 sets of parallel sides. A square has that. And you have to have all sides equal. A square has that. So a square is a rhombus. So I could call this group rhombuses, right? Can I call it squares? Well, let's see. To be a square, you have to have 4 sides and 4 vertices. The rhombus has that. You have to have 2 sets of parallel sides. The rhombus has that. All sides equal. The rhombus has that. But you also have to have 4 right angles. The rhombus does not have that. So this group has to be called my rhombus group because the square meets it has all the same attributes as a rhombus, but the rhombus does not have the same attributes as a square. So this is a rhombus. It's a group of rhombuses. So a square is also a rhombus, and a square is also a rectangle. And also a square, as you notice where they overlap, a square is just all by itself a square. It has to be its own little group as well, right? Because it shares some attributes, like enough to fall in a rhombus category and to fall in a rectangle category, but then it's also got its own thing to make it a square by itself, where nothing else can be a square, only a square. All right, and we don't want to forget our poor lonely trapezoid over here. The trapezoid has 4 sides, 4 vertices, and 1 set of parallel sides. So it's in the quadrilateral group, but it's also in a trapezoid group because there's other ways that trapezoids look. There's other ways that you could draw a trapezoid. But so we're going to have a trapezoid group over here. Trapezoids have one set of parallel sides, but they're still a quadrilateral. They're still going to fall in this quadrilateral group. And then there's other quadrilaterals that we don't talk about in fourth grade or third grade, like the kite is one, but we don't talk about that one. So there could be other quadrilaterals in other parts of this. So the main thing you need to take away is kind of thinking about and understanding that all of these are quadrilaterals. All of these four are parallelograms, right? These two are rectangles. These two are rhombuses. This is a square. A square is a square, and a trapezoid is a trapezoid. All right, let's do some questions to kind of wrap up and see kind of how we can use our information to do some true or false. So one of these statements is true, one is false. Square is also a rectangle. A rectangle is also a square. You can pause it if you would like. So it is true, a square is a rectangle. If we look at our diagram, a square is in the rectangle oval, right? But a rectangle is not in the square oval, or this little overlapping part. It's not. So a square is a rectangle is not a square. What about this one? Which of these is true? All parallelograms are quadrilaterals. All quadrilaterals are parallelograms. So it is true that all parallelograms are quadrilaterals. If I look at my parallelograms, all of these fall into this quadrilateral group. All parallelograms are quadrilaterals. But are all of the quadrilaterals parallelograms? No. Which quadrilateral is not a parallelogram? The trapezoid, right? The trapezoid is a quadrilateral, but it's in that quadrilateral group, but it is not in the parallelogram group. Okay, so guys, some of this can get a little tricky, but it helps if you have a diagram like this and you really just think about your attributes each time and look at the diagram. Like, don't be afraid to look at the diagram to help you kind of figure out which shape fits in which group and how they kind of overlap. It's okay to look at this diagram. So if you want to draw your own like this, that'd be a good idea. All right, bye. Miss you.